task sheets are used to reduce processing time. In Session 18, the operators will look at reducing any setup or downtime for the bottleneck process step. To reduce setup or downtime, prepare a setup and downtime sheet that lists all the setup tasks and reasons for downtime for the process step with the following information: a description of setup or downtime event, the average cycle time for the setup or to bring the process back up from the downtime event, the average frequency of the setup task or downtime event, then calculate the average minutes per day for each setup task and downtime event. There is a blank setup and downtime sheet in the operator workbook and an Excel version on the Leader flash drive. Like the task sheets, the process operators should prepare the setup and downtime sheet since they have the greatest working knowledge of the process. To determine the current setup cycle times, operators may be able to estimate based on their experience, or time studies of the task can be performed. You may not have much data on the downtime events since they may not occur in a consistent manner, so focus on the most common downtime events that the operators can recollect. Precise cycle times are not needed. Efforts should be focused on reducing the cycle times. Suggest ways to reduce the cycle time or frequency of each setup task or downtime event. The same methods for reducing cycle time discussed in sessions 13 and 14 can be used to reduce the cycle time of setups and downtime events. Estimate the new cycle time for each setup task or downtime event. Estimate the new frequency for each setup task or downtime event. And then calculate the new minutes per day for each setup task and downtime event. To help determine the downtime events for the setup and downtime sheet, a log of downtime events should be started that lists each downtime event and the time it takes to bring the process back up. Downtime events occur when a process has an unscheduled stop. Some downtime events may reoccur often, like the clogged nozzle in the log shown above. Some downtime events may be one-time events or occasional events like equipment failure. Since downtime events are unscheduled, a downtime event log will help in determining the amount of downtime over periods of time. The log will also help determine the cycle time to resolve the events and bring the process up. A blank downtime event log is included in the appendix. An Excel file is included on the Leader Training flash drive. For Class Exercise 23, the operators prepare a setup and downtime sheet for the bottleneck process step identified in Class Exercise 20. As mentioned, there is a blank setup and downtime sheet in the appendix. The operators will initially estimate the cycle time for each setup task or downtime event based on their experience. They can later validate the estimates with time studies of the setup task if they choose to. Using the same methods already discussed, suggest ways to reduce the cycle times of the setup task or downtime events. Estimate the new cycle times and frequencies for each setup task or downtime event. We just discussed in detail 3 tools that are used to increase the throughput of a bottleneck process step: task sheet, setup and downtime sheet, and downtime log. It may appear at this time that a lot of data and effort is needed just to eliminate a bottleneck. But consider that these tools need only to be used on the process steps that have throughput that is less than sales demand. The sheets are prepared by the operators, who should already know most of the data needed to complete the sheets. After preparing the sheets a few times, operators should be able to discern how to increase the throughput of a bottleneck process step without having to prepare the sheets in detail. Increasing sales by increasing throughput can significantly increase profits. Locating and removing bottlenecks is usually the quickest and lowest cost way to increase production capacity. The alternative is to invest a lot of time, effort, and money in additional equipment, inventory, and floor space. As one bottleneck is removed, a different process step will become the new bottleneck. Locate the new bottleneck process step and repeat the discussed steps until the throughput of all the process steps are at least equal to customer sales demand. Coming up next, sessions 19 and 20, variability.